Hello there, learners. I am Mrs. Katrina Javier Naldosa from Pasay City North High School M. De La Cruz campus, and I will be your teacher for General Mathematics this first quarter, week 6, day 3. And our lesson's objectives is to determine the intercepts, zeros, and asymptotes of an exponential function. So I have mentioned these words: zeros, asymptotes, and intercepts. When we talk about zeros and intercepts, there's something common between them. Because when we say x-intercept, those are the points lying on the x-axis, which is same with zeros. And the next intercept is what we call as y-intercepts, the points lying on the y-axis. For the asymptotes, these are the lines which are part of the graph of the function where it is nearly approaching it, but then it's still not passing through it, or it will never touch that part. So we have, for horizontal asymptote, horizontal line, we have y is equal to b. And another kind is vertical asymptote, which could be expressed as x is equal to a. There is also what we call as oblique asymptote, but those are possible for rational functions. So let's compare the graphs. I know this is familiar to you in the previous day if you have watched the video. So we have the characteristics of the graph of an exponential function f of x is equal to b to the x, where b is greater than 1. We have these three characteristics: the domain, the range, and about the observation of the graph. So what do you think is the x-intercept of this exponential function? There is no x-intercept because there is no x value that could put the function into 0. Same thing with, if you could remember, the range. The range is always positive number, so it will never be 0. So there is no x-intercept. So when we talk about y-intercept, you see that point, that is 0, 1. Because whenever we raise a number by 0, it is always equal to 1. How about horizontal asymptote? Can you see that? It's nearly, the x is approaching negative infinity, but then it would never touch the x-axis. Therefore, our x-axis is the horizontal asymptote, which could be denoted by the equation y is equal to 0. Let's have a different form of function, exponential function. I have here y is equal to 2 to the negative x, where it is reflected about y-axis, and we have this graph. So what have you observed? The equation can be written as y is equal to 2 to the negative x. So if we substitute 0 to x to find the y-intercept, it will still be 1 or 0, 1. And then, for our horizontal asymptote, it's the same thing with our parent function. That is, y is equal to 0. Let's have another form of function. Let's have y is equal to negative b to the x. This time, it's reflected about x-axis. So we have this graph. So the base here is not negative. It's the exponential expression itself. So for that one, we could identify our y-intercept, which is at 0, negative 1. So the only difference is the sign. So if the parent function has a y-intercept of 1, this one we have negative 1. So the horizontal asymptote here is just the same. We have y is equal to 0. Now, considering that particular function, y is equal to negative b to the x, a while ago, we have the y-intercept is negative 1. That is because the numerical coefficient of b to the x is negative 1. So if we have the form y is equal to a b to the x, we could say that the y-intercept is the numerical coefficient. We have 0, a. Another form of an exponential function is the f of x is equal to b raised to x minus c, or wherein there is a constant term in your exponent. So we have this graph, which is our parent function. Let me just remind you, the y-intercept and the horizontal asymptote. Now let's graph y is equal to 2 raised to x minus 1. What have you observed? Yes, there is a horizontal shift going to the right. So we have this y-intercept, which is 0, 0.5. Because if we are going to find it out by substituting 0 to x, we get 2 to the 0 minus 1. And we have 2 to the negative 1, wherein 2 to the negative 1 is just 1 half or 0.5. That's how you get a y-intercept. And for our horizontal asymptote, obviously, it's nearly approaching again, but it would never cross the x-axis. So it is y is equal to 0. Next, let's have this graph. Y is equal to 2 raised to x minus 2. So in that case, there is again a horizontal shift and our y-intercept is at 0, 0.25. So if we substitute 0 to our x, we get 2 to the negative 2 and we get f of 0 is equal to 1/4. Therefore, it is giving us a y-intercept of 1/4 or 0.25 or 0, 0.25. Have you observed the horizontal asymptote? It's still at y is equal to 0. So is there a 0 of a function? No, there is no 0 for this function because there is no x-intercept. So for the function model, f of x is equal to b raised to x minus c, we could say that the y-intercept depends on the reciprocal of the base raised to c, or the constant that we have at the exponent. And for our horizontal asymptote, it's just the same with our parent function, which is y is equal to 0. Now let's have more functions. Let's observe the graph of y is equal to 2 to the x minus 1 and y is equal to 2 to the x minus 2. So I have plotted here our parent function just to remind us the properties when it comes to the y-intercept and horizontal asymptote. That will be our basis. Now let's graph the red function. So we have y is equal to 2 to the x minus 1. What have you observed? Yes, there is a vertical shift. So for that vertical shift, we came up with a different y-intercept. It's no longer 1, but instead, it is the point of origin, which is 0, 0. So we could write there. And what about our horizontal asymptote? It also went downward. It became y is equal to negative 1. So maybe this time you already figure out how to get the y-intercept and the horizontal asymptote. Let's have another one. We have y is equal to 2 to the x minus 2. And we have this y-intercept, which is at 0, negative 1. So our y-intercept is negative 1, or 0, negative 1. We could just substitute 0 to our x, wherein it would just give us 2 to the 0 is equal to 1 minus 2, that is negative 1. So, for our horizontal asymptote, it's here at negative 2. So, we have y is equal to negative 2. What have you noticed? Yes, your horizontal asymptotes depend on your c. So, let's try to find out. Is there a 0? Yes, if you're going to observe these three graphs, two of the graphs has crossed the x-axis, and there is one x-intercept for each function, exponential function. So for our f of x is equal to b to the x minus c, our y-intercept is always 1 minus c. And for our horizontal asymptote, it is always y is equal to negative c. So for our zeros, let's just substitute y with 0. And we could get 0 is equal to 2 to the x minus 1. We could transpose negative 1 to positive 1 is equal to 2 to the x. Then we find the common base. We got 2 to the 0 is equal to 2 to the x. And we get x is equal to 0. That's for the function y is equal to 2 to the x minus 1. What about for the blue function? We have y is equal to 2 to the x minus 2. So we transpose 2. 2 is equal to 2 to the x. Therefore, it's 2 to the first power is equal to 2 to the x. And it is giving us x is equal to 1. So there you are. Let's have more examples of exponential functions, but we're going to find it out without even graphing. So we have y is equal to 5 to the x. It's a form of a parent function. Therefore, y-intercept is equal to 1, x-intercept none, and the asymptote is y is equal to 0. Next, number 2. We've got y is equal to negative 15 to the x. Yes, we have the form. We have our numerical coefficient negative 1 for the base. So we factor it out. We have y is equal to negative 1, x-intercept is equal to none, and the asymptote is y is equal to 0. Now for the next one, we have y is equal to 3 raised to x minus 4. The same characteristics so we have here the same characteristics for the x-intercept and asymptote with the parent function. But for the y-intercept, it is 3 to the negative 4, giving it 1 over 81. Next, for the fourth example, we have 5 to the x, y is equal to 5 to the x minus 25. So, for our y-intercept, we get negative 24 because that is 1 minus 25. And for our x-intercept, we have to solve for it. You get 2. And for the y-asymptote, for the horizontal asymptote, we have y is equal to negative 25. And lastly, let's have 7 times 3 to the x. The numerical coefficient 7 will give us the y-intercept. There is no x-intercept and the asymptote is y is equal to 0. Now let's sum up what we have talked about. Let's sum up about the intercept, zeros, and asymptotes of the graph of an exponential function. So for the form of exponential function f of x is equal to b to the x, y-intercept is always 1. There is no x-intercept and the horizontal asymptote is y equals 0. Or for the form of f of x is equal to a times b to the x, the y-intercept is the numerical coefficient a. And there is no intercept, the horizontal asymptote is y is equal to 0. Moreover, we have these two forms. We have f of x is equal to b to the x minus c, wherein the y-intercept is just b to the negative c. There is no x-intercept and the horizontal asymptote is y is equal to 0. And for the y-intercept of another form, it is 1 minus c, the one with the vertical shift. And there is an x-intercept, only 1. And the line y equals negative c is the horizontal asymptote. And that ends our lesson for today. Did you understand it very well? If not, you may still go back to the lesson presented in your module. If today's lesson is very clear to you, congratulations! You may now start answering the exercises in your module. Good luck and God bless!